Hello and welcome to the QA Therapy podcast. Are you looking to improve your overall testing and quality practices? My name is Sergio Freire and I'm a solution architect and a testing advocate at Xray.
And my name is Cristiano Cunha, and I'm also a solution architect and test advocate. And we'll be your hosts and QA therapists throughout this series. In this podcast, we're going to tackle some of the most common testing and quality challenges that we all face in our teams. So if this sounds good to you, keep on listening. So when we think about automating builds or CI tools, then Jenkins comes to mind. Since ideation until it gets live as a software feature, many things need to be performed. Can tools such as Jenkins help us automate this or most part of it? To assist us on this topic, we have a very special guest with us, Kohsuke Kawaguchi. So ask yourself, do you have frequent issues in your build deployment process? Or are you unsure whether certain tasks can be automated? Or even do you struggle to combine the results of test automation together with results of traditional manual test case-based testing? Or even are you somehow blind about the status of your builds and what's going on? Or even are you unsure what CI/CD tool to adopt?
These symptoms suggest that maybe you need to invest on automation and CI/CD tools. Fortunately, there are a bunch of tools that can help you and your team. So let's dive a bit into this topic. And today we have here with us Kohsuke and also known as Kike. Sorry for not spelling your word right.
That's all right. I'm Kohsuke.
And
Hey, thanks for having me.
it's our pleasure. And he will be our expert QA therapist to assist on diagnosis and prescription on these symptoms. He was the creator of Jenkins, and I think that it says it all. Tested and many tasks have been out. Many software that we know have been built automated using Jenkins. So kudos to Kohsuke and the community that supports Jenkins. Nowadays, he is also embracing new challenges, testing related, that we'll talk ahead. Welcome. Are you comfortable on our QA therapy couch?
Yeah, thanks for having me.
Can you tell us a bit about how Jenkins and Hudson were born and the reasons that led to its appearance?
Sure. So it's been, I think this must have been 2004 or something. And just saying that makes me feel old. But I was working in a team of 4-5 engineers working on one part of the Java EE platform, which actually, now that I think about it, for the people here, the idea of Java EE might already be a part of the history, but that was a server-side, application development platform for Java. I used to be a guy who breaks builds all the time. So my colleagues occasionally called me. And yes, this was a time when you had this phone in your office. And then, hey, I updated my workspace and the source code no longer compiles. And it looks like you're the one who touched here the last time. And can you check what's going on? And sure enough, maybe I sometimes break the test without knowingly, or I just even forget to commit some files when the other half gets committed. And as I thought, well, that was kind of embarrassing. I thought, well, why don't I write the program that catches that problem before my colleagues do? And then turned out that when I actually started doing that, I wasn't the only one who was breaking the build all the time, but that was one of the motivations. And I also wanted to write an application by myself using the platform Java EE that we were producing. That felt like a basic engineering satisfaction, right? You're producing something, you kind of want to use it. And it turns out that when I looked around, not many people working in a team were doing that, and then I didn't. So I was like, okay, this could be a good opportunity. So that eventually led to what became Jenkins. So that's the origin story.
So it's like to solve your own problem, and the engineering problem that you had having. You created this tool, and do you think that Jenkins has changed a lot of the development area? So after it appeared, because I'm from that time. I was without Jenkins and with Jenkins, and I can't really remember what it was before Jenkins. So for you to know the impact that it has, because it has like the default tool that we are going to today. So do you think it has changed anything on the developments of that area?
Yeah, I mean, I wouldn't take the credit that the Jenkins had changed it, but it was sort of like one of these, thread or one of the factors that combined with all the other things that were going on at around the same time, I think made a significant impact in the software development landscape. And I think that's probably mainly this idea that the servers needs to harness the software development. So prior to that, I think mainly the software development was thought as an activity who you do with the computer in front of you, like a workstations that you do in front of you. And so it's fundamentally like a team, like a single person activity. And then it's like a version control system was built, like a bolted on top of it as a means of collaborations. But I felt like what was going on back then was, the computers continued to get cheaper, engineers remained expensive, or became even more expensive, and the cloud was happening. And then so people needed to use a lot more computers to make themselves productive. And I remember, unlike you, that the back then some people used to use a cron tab, like a cron to run, set it. Oh, I'm gonna run this script nightly, and then maybe send out the email every night as a result of that. But that was obviously very inconvenient. So that thereby, I think, created the room for something like Jenkins, where you can put whatever workload that you want to run on servers, and it just became like yeah. So that's, I think, its main contribution.
Yeah, for sure. Visibility and collaboration, I think, are two of the biggest things that has changed, because it brought the visibility over the entire team of everything that's happening on the build process, on the testing process, on the deployment process eventually. And it's put collaboration.
Visibility, I think, is actually a great point, because also around that time, what we were doing is like people in the same team don't necessarily even agree on the status of the tip of the repository. Like that this is, whether it compiles or not, or is this test currently passing or not. And then so just having this one place, everybody can go and see and talk about the same thing. That alone was useful. So I think great point about visibility.
Yeah, but Jenkins, when it comes out around, well, it was one of the big points. It was really customizable, so a lot of custom things, a lot of plugins that you can add for the good and bad, of course.
Right.
And then we enter also the era of Jenkins X. So how different was it from Jenkins?
Yeah, so the Jenkins X was, what I think of it is a rethink or reverse of Jenkins around Kubernetes. So that was, I guess it still is, but is a major, like a tectonic shifting force in the how we run compute. And the kind of, so one key part of Jenkins is you manage this, I guess, what people think of the build machines, right? The environment in which build and test happen. So there's a lot of effort, like a lot of code spent inside Jenkins to manage those scheduling and stuff like that. But if that is clearly that was becoming more of a commodity, like the universal layer that is the Kubernetes. Well, then can we, like, if that's to be delegated, then that could have been, we could have created like a fundamentally different architecture. And also, this, because Jenkins started in 2004, fundamentally it's like a single process server, which back then was the normal thing, but now you didn't design systems like that. So that was also opportunity to kind of reset that, make the whole thing ephemeral. So that's sort of like led to the Jenkins X project, and I'm glad that something like that, it's a hugely different, like very different idea came out from the project, and that's been wonderful. Yeah.
For our listeners, what can you do in what matters testing with Jenkins?
Right. Well, I think scriptable, automatable tests are fair game for Jenkins, and I think people kind of use it that way. So I've seen everything from the unit test, the performance test, or the security test, or integration test, or like just a whole bunch of workload, and scheduled to run at certain point or on the certain event, and then like a sharing the results. So that's I think that's yeah. So workload wise, that's kind of what happens. And then so what I noticed is that one, like when you can automate the execution of the tests, and then when you run it frequently, you can just get a lot more value out of the same investment in testing, which in turn create more incentive to spend a little more time in testing. And I think for the people who take testing seriously, that's a good thing. And then we talked about visibility a little. So when you put the test results in visible place, like Jenkins or through Jenkins in somewhere else, then a lot more devs and engineering managers and other stakeholders start to care about them. And I think we all know that the QA is sometimes a very invisible, unappreciated, thankless job. That unless things like kind of blow up, so I feel like that help that extra visibility is not only important to get the results fixed, get the work, get the things worked on, but also what the QA people are doing.
I remember that when I started adopting Jenkins a really long time ago, one of the biggest challenges that I had was around, let's say, the stability around the ecosystem, about all those plugins that would sometimes and very frequently break the existing functionality. I'm not sure if you know how this is currently, if it is more, let's say, stable, or if this is still like a challenge.
Right. So I think it got us much better. So what, for example, like I know that in the community nowadays there's this set of plugins that are tested together to work well. So every time the base Jenkins bumps up, I believe like those things get updated, and then there are individual plugin tested run against those. So I think there's this growing understanding that some of the core functionality at least needs to work together well. So we also took on, well, this is years ago, but the notion of like a long-term support. So the Jenkins project has been doing continuous release itself, like every week. We release every Monday. We release the new version every Sunday, I think. We release a new version. For the longest time, I used to run from the computer here, but that was and then that continuous stream model has been, I think, useful in getting the changes out there quicker. But for people who didn't want to update more frequently like that, we offered like some versions, I think, every month. Like we set aside some version and then kind of kept on backporting some security patches and stuff like that. So that was good. And then eventually, like Jenkins led to me being a CTO at CloudBees, and the CloudBees offered some commercial solutions. And one of the things they did was they offered like a tested, certified version of Jenkins, and supported that for long term. So people who kind of wanted to make things easier for themselves could have used it. So yeah, so I think that the program was well recognized. But I think it's also important to point out this is the kind of two sides of the same coin. When you have this like a vibrant open source community in which people came with their idea of what they wanted to do in the CI, then it's naturally like.
Yeah, for sure. And like you said, everything has evolved since then. So Jenkins has evolved. You have built Jenkins X, and then meanwhile, software and the way that we deliver software, the way the software operates has also evolved. So, what are
Right.
now the challenges that you see in software development, in your point of view?
Right. Well, let's see. I mean, in some sense, like the fundamental challenges of the software development haven't really changed. But just to name a few, for example, well, we are still under the pressure to deliver faster, and that's always tricky when the software also needs to be in high quality. I feel like that balance between, like this sense of being between the rock and the hard place. We got to deliver more things faster, but like it has to be more stable. That's always with us. We never had enough engineers to work on the like a problem that the world needs us to solve. So like making software development more accessible to less capable people, let's say, has been always more important, which kind of led to the idea of like relying more on the computers. Testing is still freaking hard. Except a few pockets, and I got somewhat better. Like a testing through the browser got a little easier. But like I talked to all sorts of teams in which they are dealing with the real world, like embedded software development, mobile, cars, in which just testing is still hard. Automation is very hard, and I think that still remains. I don't see that fundamentally changing.
Since we are really talking about this challenge about how to optimize our let's say testing or automated testing in this case, what can we do about it? What's the problem and what can we do about it?
Mm-hmm. Well, one of the things, I think like the first layer of the program is kind of knowing what tests you're running and how they're behaving. And I mean, people know surprisingly little about those things. Like they might roughly know how long the test overall takes to run, because like that's a feedback loop they are aware of. But what tests are actually, what tests are like fading from time to time, which is actually catching a problem, or like which test is just not fading forever. There's actually a surprising number of tests that take forever to run and never fail, which at some point you get a question like, is that a test that's worth keeping around? Is it like cats that they do not catch any mice? So just knowing those things is helpful. Another example might be the flakiness. Like sometimes the tests would pass and fail, like seemingly randomly. Like, if you're a dev with the project long enough, you kind of know what these are. So when you see a failure, you could say, oh, this is probably nothing to do with my change. I'm just going to rerun it. Junior people like waste their time looking at those failures. In any case, all these things create some unnecessary friction. Like when the change needed to land into, say, QA branch or a release branch, like this random flakiness, it's going to prevent that, and people have to waste like a midnight oil doing that. So knowing those things is helpful. And then you talked about like a running tests that are more to the point. Toward the end of my involvement with the Jenkins project, like it had amassed like 16,000 tests, and so even a single line change would have to go through like a 1 hour of the testing cycle. And it makes you wonder, like, okay, clearly, like if I'm changing this one method, I don't think I need to run this Windows, the Windows file system test, or Solaris Symlink code or whatever, right? So, but it's just, you kind of tend to run these things. So I think that is the emerging practice. Like, how can you, test is one of the quote unquote the big data domain in the software development. And then so if you have that like a mass of data available everywhere, there's like a certain critical mass of data is available, we were able to use that to make it like to learn like useful insights, actionable intelligence out of it. That's a whole big data movement is about. And it turns out that I think the software development should be also subject to the same thing. And then in particular testing. So, yeah.
Yeah, really interesting. So what are you working actually
Sure.
nowadays, and what you are trying to solve? I know that you have a new tool around.
Yeah.
So what is it,
yeah, so,
and
right.
and what you're trying to solve with it? Because it's related to testing this time.
Right. Yeah. So in a nutshell, like I'm thinking about, okay, so first I'm going to grab all the test execution results and how your code is changing. And now, like I'm turning that raw data into value for the software development team. So one of those, for example, is just this, the show you maybe the test results. Right. So that seems like a pretty mundane thing. Every CI system has it, including Jenkins. But it turns out that I think that is where people actually spend a lot of effort, like a triage, if you might want to call it that. You made a change, the test failed, which is a feedback. So now you got to decide what to do. And I've talked to many teams who said, well, the first thing I want to check is this like a CI server acting up? Then that error needs to be directed to the CI people. Is this like an application change breaking the test, and that got to be looked at by the app team? Or is this the test needing update, in which case it has to go to the QA team? So that's like those things, those are part of what triaging does, and then I'm trying to help them easier. Or like, oh, this test result is flaky, then you might say, okay, I'm not going to look at that. I'm just going to like fix the one that I broke and then rerun it and hopefully that it tests next time. So the next layer of information from there is just giving them the overall visibility into test as a whole. So if you're a QA manager or engineering manager, like one of the signals that you're looking at is like if the test failure rate in the dev environment suddenly goes up, then that's a sign that something is amiss. So it gives you this like a pulse on what's happening in the QA. Or if you decided that, okay, you want to spend time in the automated testing effort, you want to be able to show the impact that it made. So we quantify those things. I think in my sense, at least the people I talk to, most of them want to do more testing. It's just that they couldn't justify spending time on these things because they have competing priorities, right? They gotta deliver more features. Like nobody, like a business people or product managers don't like, well, I mean, it's kind of against their interest to spend they're spending time something other than delivering features. They get that these tests are supposed to help eventually deliver faster, but sometimes that's hard to connect, right? So I think with these numbers it help them make the case. And then our crown jewel, or what I'm working on, is what we call the predictive test selection. So this is something that the Facebook wrote a paper about. And it's kind of funny to think that even some sophisticated teams like that in the Facebook engineering team having this QA program, really, like they had this too much testing problem. You have this massive application that is a Facebook. They have massive tests and all sorts of development going on. So when something changes, how can you quickly get that to production without running all the tests? So they deploy the machine learning to figure out, okay, if this code changes, these are the worthy tests to run. So yes, I thought, yeah, that made sense. Like I could have used that in building Jenkins myself, and I know a lot of teams struggle. So why don't I turn that into some generally useful solutions? And that's what it became like a launch pad for my current company, Launchable. But in any case, the whole idea, all of those is kind of comes under the same banner of reducing the friction and the heat from the delivery process. Like get the changes smoothly going into production and evicting the bad ones through the process. So,
yeah, I think what you said about having these applications that are here for a decade or half a decade, and the cumulative tests that they have just putting through their pipeline are just accumulating now. So they have a lot of tests running. So having a way to understand what tests to run instead of running everything, it's really useful. So good catch on that. But that also means that you need to go over a lot of data of those results that are just put it in to take that decisions. And now what we have been seeing is the appearance of AI and ML and ChatGPT and business intelligence. So all of those things to help on that. So how do you see this AI ML helping on the software development and on testing, and how are you using it already or thinking of using it on your new project?
Yeah. So a classic, by classic I mean like the past 3 or 5 years, I felt like the main focus for the AI and machine learning is to shift through large amount of data. So I think it's production monitoring companies are probably the fast. It's like an anomaly detection. If you have lots of metrics that you're tracking, it's like it's more than what the humans can deal with. So they deploy the technology that says if the graph started acting up, well, like something happened, and then they raise that signal. So it's like the control pane to see what's going on. So that was I think the first use of AI in our space, and that's I think something like that is actually quite needed in the QA space. I'd argue, like test failures. Like now they are just too numerous for humans to directly look at. So I'd rather like somebody like AI to come in and say, well, okay, this is flaky error.
Tools such as Jenkins that led us to this initial conversation, they exist because they're mostly to automate tasks. So, but then this question comes: how do you see the role of the team members in non-automation related tasks like brainstorming or even exploratory testing?
If anything, like automation became such a big part of the software development process that it became a specialized job, right? Like you go to these teams and they have a CI guy or a build guy, and then what he's actually doing or what they are actually doing is to control the whole like automation black box. And in some sense, like that leaves most other engineers out of the automation picture, which I guess it's probably a good thing, right? So, now you mentioned exploratory testing. That's actually an interesting one that I don't have too much visibility because historically, I've been more focused on tests that can be automatable. But we all know that not all tests are there's not all tests are automatable. It's not particularly productive to do so. So I recognize there's always some parts of the test that's not meant to be like that. But that is the area that I have very little visibility on. So you have to think of it. Might be useful to think about how I don't know, AI or whatever could, or tools like Jenkins could assist that kind of exploratory testing. So some people seems to have this like a magical capability to do it well, but other people didn't, so anyway, yeah. So, but I don't know what do you mean, like role of brainstorming?
I mean, for example, whenever you're like say launching your new product that you are working on, it's not just about building the code, no matter if you are talking about the code of the software or even the test automation code. It's also about having these discussions within the team about clarifying things, like testing without actually writing code, like testing the ideas, right? So I guess you have many of these interactions where you discuss things even before you actually commit them, right? And actually before, like shifting totally left. I mean,
I got it. Okay, so in the context of QA, right? Yeah. So I think maybe one thing that has changed is that the testing used to be seen as a gate. Like it's something. Maybe it's like the carryover from hardware days, in which you produce stuff and you check if that is all right. But I think that is changing. That like testing, in some sense, I think the QA and like testing and development are more unified. Like architecturally, like you design things to be more testable, or like you develop other means to assure QA, right? Like nowadays, I think
have you seen this? Let's say in practice, let's say more development teams assuming, let's say, testing continuously, not just waiting for someone to say, okay, this is good or not good.
Yeah. And then I don't mean just testing continuously, but for example, so I remember, I think it was an Airbnb engineering team made a post about their mobile development framework. So the mobile app is, one of the harder ones to test for all sorts of reasons. So they took that really less than seriously, and then they built the mobile app framework with the testability like hard baked into one. So they could mock out any state that the application would be in. So it became somewhat like, I mean, in some sense, like you could say it's bringing the web app technology into the world of the mobile app, which is kind of is a common thing. But so that's one example. Or this idea of like A/B testing or like a circuit breakers, and those are another ideas in which we accept that the production, like we can't weed out all the problem before things get to production. So, but let's make sure that the blast radius, if something goes wrong, is small enough. And then so I consider that to be a broadly quality testing effort, but it's not in the form of a gate. Right? So I think that is a very important change, I think.
Thanks for being here with us. Kohsuke, and tell us more about not just thinking, but all the whole world of automation, and also some about some things about the future ahead and some things that are already available.
Thanks for the opportunity. And I'm passionate about automation and testing and QA. So if some of you listening to this podcast wants to talk more about these things, drop me a note, and I'll be happy to have more of these conversations. So once again, thank you.
In this case, we'll be talking about Vitamin X, where X stands for Xray. Xray provides support for easy integration with your favorite CI/CD tools, including Jenkins. The integration can work in both ways, triggering a pipeline from a test plan or test execution, or pushing the results from a job in the pipeline. There's an open source Jenkins plugin that you can use to easily upload your test automation results to Jira and share them with the rest of the team using Xray. This way, you'll be able to have full traceability and track the impacts of your test automation results directly on your user stories or epics, alongside with other testing results coming from manual testing. The Jenkins plugin supports standard projects such as Freestyle, where you can use the UI to configure. Additionally, there's also support for pipeline projects. The ability to trigger a pipeline to execute automated tests directly from a test plan or test execution is also a must. And with Xray Enterprise now you can. With the new remote job triggering, you can configure triggers to several CI/CD tools like Jenkins and trigger the job from a test plan or test execution issue. All of this without leaving Jira.
And we've reached the end of the episode. And in this episode, we have seen that Jenkins enables teams to automate many of the tasks related with the software development process, including compiling, testing, packaging, and deploying. The way we build and deliver software has been changing. So have the tools and the teams. Part of what we do needs to be automated for efficiency and systematic reasons, so we can stay focused on activities that are indispensable. Therefore, we need to try, experiment, fail, and adapt. We cannot put tools aside, but we also should not get blind by tools. It's essential to give teams the flexibility to choose the best tools that suit their needs and still be able to have an overview about what is going on, namely from a quality perspective. So, see you in our next QA therapy session to share and learn together. So, see you in our next therapy session. Happy testing!
Happy testing!